Alright, so we're going to look at 1.2, analyzing graphs of functions and relations. So we're going to start with example 1, where we are asked to use the graph to estimate the value of the stock on the 10th day and then confirm our estimate algebraically. We're given the equation for our function here. So we're going to start by looking at our graph. So looking at our graph here, we have, looking at our 10th day, we're going to go up, and it appears at day 10 we intersect our graph here, and so going across is going to be something slightly above $30 per share. I would say maybe about $32. So from our graph we have approximately $32 a share. We're going to check that by plugging 10 in for D into our equation. And so just every place there's a D, we're going to substitute in. So we have Alright, so I'm going to plug it in to my calculator now. And plugging that into my calculator, I have that V of t, V of 10 equals $32 per share. And then the part B says use the graph to estimate the days during which the stock was valued at $30 per share. So removing that so that we can look. So every place where it's 30, my graph crosses at 30. So it appears at 0 at day 0. And then again at 9. And then again at day 13, we have 0. And to confirm that, I can just plug each of these in to the equation to see. Now, when I plug 0 in, it looks like I'm going to get 31, which is slightly more than the 30. So perhaps it's really at day 1. But we would do the same thing here. So these would be our D's, so we plug these in to our equation, and if we get 30 out, then we know we're correct. So for our next example, we want to find the domain and range of this graph. The domain is the set of all points that can go into the equation. So in this case, since x is the variable that's in the equation, our domain is all x values. And our range is what comes out of the equation, and our y values on our y-axis are our range. So we're going to look at what values can we plug in to our equation and get a result. So looking at this, looking at our x value, we're continuing indefinitely. So for this particular graph, our domain is going to be all real numbers. So if I'm graphing that in interval notation, I'm going to go from negative infinity to positive infinity along my x-axis. And then looking at our range, we don't have any limitations, even though we have a maximum point here, because the sine is continuing to go up. We're going to have all positive, all the way to positive infinity on our x-axis. And even though we have a minimum value here, because this is continuing on, our range is also going to be all real numbers from negative infinity to positive infinity. This example is a little bit different. So still finding the domain and range. So our domain is still all of our x values since x is our input. So looking at all of the values that can go in, if we go down here, our graph is still continuing to go to the left. So our domain minimum values are going to be from negative infinity all the way to positive infinity, because no matter what value we put in along our x-axis, we're going to get an output. Looking at our range, however, we have a minimum value here. To me, this looks like a little bit above 2. I'll say 2.5. So looking at our graph, we have a minimum point of 2.5 where the graph stops. Now it looks like it can be that point, so I'm going to do a bracket. And then as we go up our y-axis, we do not have any limitations, so it's going to continue to positive infinity. Alright, so now we're going to look at our y-intercepts. So if we're looking at this graph here, we're going to look at it graphically, and then we're going to solve algebraically. So our y-intercept is where our graph crosses the y-axis. And on our graph, we can see that that's right here. That appears, if this is on a scale of 1, it looks like it is at 1. So now let's confirm that algebraically. So our x-coordinate of the y-axis is always 0, because that's where we're crossing the x-axis at, is at 0. So to confirm algebraically, I'm going to plug 0 in for t and solve it out. So 4 times 0 is 0. We have y equals 0 plus 1. 0 plus 1 is 1, so we have square root of 1. Square root of 1 is 1. So we have 1. And so, obviously when you square you get plus or minus. But because we cannot have negative numbers with our square root, we only consider the positive. So we have our y-intercept is at 0, 1. So for this example, we're going to find the roots, or the zeros, and this is where the graph crosses the x-axis. And in this graph, we can see we have 3 different spots. We have here, here, and here. So to find where these cross the x-axis, we're going to factor. We can take out a greatest common factor of x. So we have 3x squared minus 10x plus 8. I'm going to use slide and divide method since we have 3 in front here. So I'm going to take this and slide it to the end. So 3x squared minus 10x plus 24. So I need 2 numbers that when I multiply together I get 24. The same 2 numbers when I add together I get negative 10. It's going to be